Alright guys, so today we're going to take a look at how we create linear equations, specifically the slope-intercept form given a graph. Okay, so these first 8 problems are going to be kind of not review, kind of the notes. Okay, some examples. So we're going to talk about those. Then you're going to have time to work on the other parts, and we're going to, kind of check as we go. Okay, so we've spent some time graphing. Well, we spent some time creating equations out of a lot of things. Then we started graphing equations. Now we're kind of going back to creating some equations, okay, from those graphs. Okay, so first thing though is making sure we understand the slope-intercept form. Okay, that is the y equals mx plus b, or if you prefer, you could write it y equals b plus a times, nope, using the wrong letters, a plus bx, okay, where the y-intercept, the starting number, is either that a or b depending on which formula you're using, right? That's our y-intercept. We also call it our start number. Then we also have our growth, which when we talk about linear graphing we call slope, right? Our growth. So basically you need those two things, okay? You need the y-intercept and you need the slope. Once you have those, you just insert it into your equation, right? The slope right here and the y-intercept right there, okay? So that's really all we have to do here. So we can use the graph to figure that out. But first I just wanted to talk about a few, I guess, easier problems, a few kind of things to warm us up, or a few different ways you can see it, okay? So if we look at number 1 and 2, they already give us the slope and they already give us the y-intercept, okay? So all we have to do here is put it in the equation, right? Again, y equals mx plus b. So I'm going to start by writing y equals. By the way, you guys should be following along. If you need it paused, then ask Mr. Vorwaller or the guest teacher to pause it for you. And you can catch up and then we'll keep going, okay? So this is all we're working on today, so not too bad. I expect that you guys are paying attention and working hard, not falling asleep, okay? So y equals, then I grab my slope. Negative 1/2. Slope always has the x with it, so I put an x there. Then my y-intercept is a positive 3, so I'm going to put plus 3. And there's my slope-intercept equation. Now, if you decided you prefer this second way to do it, that's just fine. We'd go y equals positive 3 minus, because it's a negative, 1/2 x. Same thing. Okay? So number 2, try it on your own real quick. Okay, same idea though. We go y equals our slope 7 times x. Then we've got a minus 3, so I can put plus a negative 3. Okay, you can put it that way, though personally I just prefer to put minus 3, just like that. Okay, again, if you wanted to do it the other way, y equals negative 3 plus 7x, same thing. Okay. So that's essentially what we're going to be doing, is creating this as we go down, okay? So let's skip 3 and 4 for a second, and let's look at 5, 6, 7, and 8, okay? So what we're needing to do on these is we need to find that slope. We need to find the y-intercept on all of them, okay? So we want the slope and the y-intercept on all of these. The slope and the y-intercept. Okay, once we've got that, then it's just a matter of like 1 and 2, just putting them into the equation. Okay, now we know the slope here is rise over run, right? I also call it the change in y over the change in x, delta y over delta x. That vertical change over the horizontal change, okay? So when you look at your graph, you need to pick 2 points, okay? Now, it doesn't really matter which 2 points you pick. However, there are some that are better than others. Because if we look at number 5, okay, what we want is we want points that are here on, at the intersections. Because then they're whole numbers, like, 1 negative 1 1, or negative 1 2, or negative 2 2. Okay, if you pick one here in the middle like this, we have to estimate, and that's going to make it tougher. Okay, so if I look at this, that one almost is there, but not quite. On your paper, it might look better, but trust me, it's not quite there. So as I look, it looks like we've got one up here, and we've got one down here. Okay, so identify those 2 points. And then I'm going to find the y-intercept and the slope. Well, the y-intercept's an easy one because it's right on the y-axis. So it looks like that is 5 because the point is 0, 5. Okay, so my y-intercept is 0, 5, but we kind of just think of it with the y value of 5. Okay, whereas this one is negative 5, negative 1. Okay. So what I'm going to do is just see how far up I have to go and how far to the right to get to the next point. We always want to start with the point on the left. Okay. We always want to go left to right, basically. So we see I go up 1, 2, 3, 4, 5, 6. I go to the right 1, 2, 3, 4, 5. So it's rise over run. So I go positive 6 over positive 5. Because I'm going up and to the right, they're going to be both positive. Okay, so I have my slope of 6 over 5 and my y-intercept of 5. So we go y equals 6 over 5x plus 5. And there's my equation. Again, you could go y equals 5 plus 6 over 5x and it would work. Now, from now on, I'm just going to give you the slope-intercept form because that's typically what it's going to be like, okay, as opposed to our, I guess, more arithmetic geometric or arithmetic format where we did the start first and then the growth. Okay, but if you prefer that way, keep doing it that way. Just make sure you have your numbers right and you're good. Okay. So, again, first thing we got to do is find the y-intercept. Okay, if I look at number 6, I can see here, again, as I look at my points, I've got a point right here, point right there, right there, right there, right there, and right there. So I just picked 2 of them. Now, in a second, I'll show you why it doesn't matter. You just pick 2. I'm going to pick my y-intercept as one of them because that seems like that's an easy way for me to kill 2 birds with 1 stone. So my y-intercept is 0, negative 5. That's its point. But again, we think in terms of just the y value, so negative 5. Okay. Then I've got all these other points to choose from, don't I? Okay. I typically would just go with the nearest one, the simplest one. Okay. So I'd go with this guy right here, which is 1, negative 3. So we'd go up 2, to the right 1. So my slope would be 2 over 1, which we could call 2 over 1, or we could just reduce that to 2. Okay, I think reducing to 2 is probably simpler. So then I just go y equals 2x minus 5. Again, I could put plus negative 5, but I think minus 5 is better. Okay, now you'll notice I've been writing the points. You can actually find the slope based off the points. Okay. I don't think it's as easy as just looking at the graph, but it can be done. Okay. And the way you do that is you just take one y value, subtract the other y value. So negative 3 minus negative 5 over that same x value minus the other x value. Doesn't matter which order you put them in. It does matter, however, that whichever these points stay together, right, like negative 3 over 1 or negative 3 over 1, okay? But if I go negative 3 plus a negative 5, or plus a 5, minus a negative is really plus, right? It would be 2. 1 minus 0 is 1, 2 over 1. If we did it the other way, negative 5 plus 3 would be a negative 2, and you may think, oh, this is going to be different. However, 0 minus 1 gives us negative 1, and negative over negative is really a positive, okay? So it actually works out to be the same thing, okay? All right, by the way, this was our answer, okay? Giving you guys a lot of extra information, aren't I? Alrighty, so let me take a second and erase some of this stuff. Okay, clear us out some space. Hopefully you had that written down. Oh, I was going to show you why it doesn't matter which one of those you choose. Okay, so back here anyway, put those points back. So you may think, well, if I chose different points, it's going to be different, right? It isn't, because the slope is always going to be the same. So watch this. So here we went up 2 into the right one, right? And we had 2 over 1. Well, if I go up further, 1, 2, 3, 4, 1, 2, I get 4 over 2. What does 4 over 2 reduce to? 2, or 2 over 1. Okay, so if I kept going, 1, 2, 3, 4, 5, 6, 1, 2, 3, 6 over 3. What does that reduce to? Again, it's 2. Okay, so because of the way the nature of slope, it doesn't matter which ones I choose. Okay, I could pick this one and this one. Go 1, 2, 3, 4, 5, 6. Maybe we actually went up to the top. 7, 8. 1, 2, 3, 4. 8 over 4. It still reduces down to 2. Okay, so it doesn't matter which ones you choose, as long as they're good points, you'll be good to go. Okay. All right, so kind of think about 7 and 8 on your own real quick. We'll get back to 3 and 4 in a second. Okay. Erase this again. All right, so looking at number 7. This one we've got a ton of points, don't we, to choose from. Again, you only need to pick 2 of them. Do you need your y-intercept? So this guy right here at negative 1, right? 0 to negative 1, or just negative 1. And then I pick 2 points. Let's pick this point and this point. Again, like I said, always go left to right, and I would always pick the ones that are closest to each other. So I'm going to go down 1, so it's a negative 1, to the right 1. So my slope is negative 1 over 1. Okay, so I can write it negative 1 over 1, or I can just simplify it to negative 1. Okay, then I write my equation, y equals my slope, negative 1x, minus 1. Now, sometimes you'll see this just written like this, negative x minus 1. Okay, because of that multiplicative identity property of 1, we can drop the 1 if we want to. We have to keep the negative, but we can drop the 1. So it's fine to just leave it just like either one of those, okay? Though this one you'll probably see more often than not when other people are doing it. But it's still the same thing, okay? All right, number 8. So it looks like we got a good point right here, right here. There's our y-intercept, so our y-intercept is 0, 2, or just 2. That point and that point. So then I pick 2 points. Let's go this guy and this guy. Again, I'm going down because I always go left to right. So down is negative, and then to the right, 1, 2, 3, 4. So I get negative 2 over 4, which we should reduce fractions, okay? Now, the great thing is if you're using our calculator, you can just type in negative 2 over 4, and that would say, oh, that's negative 1 over 2. And it would reduce it for you if you're not that great at reducing fractions. If you would like to just reduce them by hand, just recognize they both can be divided by 2, which gives us negative 1 over 2. Now, would I mark it wrong if you put that in? Probably not. However, sometimes some people would, because they always say reduce, reduce, reduce. So then we go y equals our slope, negative 1/2 x, plus 2, because it's a positive 2. Okay? Now, sometimes you may see somebody would write this, y equals negative x over 2 plus 2. That's the same thing. Okay? that x can kind of sit up top there if it really wants to. It can't sit on the bottom though. Negative 1 over 2x would be wrong, so don't write that one. Alrighty? Okay, so there's some examples for you guys. We still haven't talked about number 3 and number 4. Now, sometimes they'll just give you an equation in what they call standard form. Standard form is when you have a number times x plus a number times y equals another number. Okay? It's just called standard form. Standard form is great when you're given story problems that deal with two different things. Like say x is shirts and y is socks. And you're going to buy 10 shirts or I guess cost of shirts is what I should say, cost. You're going to buy 10 shirts and you're going to buy 12 pairs of socks and you have $50 to work with. Okay? That's kind of an easy way to set it up when you're given the two variables, not in terms of like the starting and growth style, which we're pretty much used to. Okay? So that's kind of where this standard form really comes into play, is doing that. Okay? But to change from standard form, because sometimes they want you to take the standard form because that one's harder to graph, and they want you to put it in that slope-intercept form because that's a lot easier to graph. Okay? So basically what we should notice is with our slope-intercept up here, right, we've got the y all by itself. You've got the x term over here and the constant term. So we've got to get this constant term, this x term, on the same side, and we've got to get this y all by itself, so we got to get rid of that negative 3 in this case. So if there's a coefficient there, we've got to get rid of it. Okay? But it's pretty simple. Basically, we're just relying on some of those solving skills that we did so long ago, so good little practice. But basically, when it's standard form, you start by adding or subtracting your x term. So I'd subtract by 2x on both sides. Okay? 2x minus 2x becomes 0. We know we can drop 0, so I'm left on the left side with negative 3y. Okay? And that is going to equal, well now, this negative 2x, I can't combine to the 6. It's not going to be 4x, so I can just rewrite 6 minus 2x. Or I could rewrite it negative 2x plus 6. Okay, you may want to change it that way, but you can wait till the end to do that if you'd like. Okay, then we got to get rid of this negative 3. So to separate it, I'm just going to divide. So I divide everything by negative 3. Okay, sometimes some teachers will just write 1 here, but I like to keep them separate just because I like to remember I'm dividing everything on that side by negative 3. So negative 3 divided by negative 3 is 1, which just leaves us with y because of that multiplicative identity, which is what I want, right? Then I've got 6 divided by negative 3, which is going to be negative 2. Negative 2 divided by negative 3, I don't know what that is, but I know negative divided by negative is a positive, so it's positive 2/3 x. Because my slope is generally a fraction, I'm just going to leave it as a fraction. Then I'd probably rearrange it to get y equals 2/3 x, since it's a negative 2 minus 2. So that is the slope-intercept form of this equation up here. Okay? So they're the same equation, it's just this one's easier to graph. Now we can graph from the standard form, but the slope-intercept form is just that much easier to do. Okay? All right, so number 4, same idea. We'll use green for this one. So I've got a positive 6x, so I'm going to start out by subtracting 6x. Okay, that becomes 0. I'm left with 3y equals my negative 6x. We'll put the slope in first, and then positive 18, so I put plus 18. Then my next step is I divide everything by 3. That becomes 1, so I get y equals negative 6 divided by 3 is negative 2x, plus 18 divided by 3 is going to give us 6. So I get negative 2x plus 6, which then I could use to graph. Okay? Alrighty, guys, so that's the examples. That's kind of some notes. So now what we got going on, okay, is we've got some problems for you to work on your own. Okay, so we've got some where it's just given the slope and y-intercept, write the equation. We've got two where you actually have to take the standard form and write it in slope-intercept form. Then we've got a bunch of equations to deal with, okay? So, and we'll go clear till looks like 32, right? All right. So let's do this. Let's do it in pieces, okay? So let's have Mr. Vorwaller give you some time to work on 9 through 14, and he can determine how long that is. So he'll pause the video. You guys can all work on 9 through 14 and let go with whatever Mr. Vorwaller says in terms of if you're working together or not. Mr. Vorwaller's in charge, so you guys make sure that you do what he's telling you to do. Okay, and then you can watch the video and kind of correct yourself. So we'll kind of correct ourselves as we go, okay? So you need to pause the video now and give him however much time you want to give him. All right. Sorry, I needed a drink of water. I wouldn't have made the pause that long. So, you should have already done these ones, so let's see how you did, okay? 9 through 12, we easily should have got. 13 and 14 might have been a little more difficult. Okay, so our slope of 4/5, so I got y equals 4/5 x, y-intercept of 3, positive, so plus 3. Okay, number 10, y equals our slope of negative 3 over 5, x, because that's our slope, y-intercept of negative 2, so minus 2. Unless you did negative 3/5 x plus a negative 2, that works as well. Or a negative 2 minus 3/5 x with the y equals. Okay, but I would probably just get in the habit here of doing it in the slope-intercept form. Number 11, y equals positive 3x minus 5. Number 12, y equals negative 3/2 x plus 3. Okay, so that's how we should have done those first four. If you made a mistake, hopefully you can spot the mistake or get Mr. Vorwaller to help you out realizing what you did wrong so that we can fix that and we can do better, okay? Now, on 13 and 14, we were supposed to change it into that slope-intercept form, right? So we got to get y by itself, basically. So I'd start by subtracting 9x from both sides, giving us, hopefully you kept that negative with the 5y. We've got negative 9x plus 10. Then we divide by negative 5 to everything. That becomes 1 and positive. Negative over negative becomes positive 9/5 x. Okay. Hopefully you didn't turn it into 1 4/5, or I believe that's like 1.8. I suppose you could put 1.8x, but because of the nature of slope, it's easier if you leave it as a fraction. And then we've got a positive over a negative, so it's going to be a negative. 10 divided by 5 is 2. So you should have y equals 9/5 x minus 2. Now, if you don't quite get 13 and 14 as much, that's okay. We won't be using those ones as much as the other ones, okay? All right, now number 14, we'd start by subtracting 7x from both sides. Again, negative 2 and negative 7x can't be combined. It'd be negative 7x minus 2 equals negative y, because the negative stays with the y. Now, this negative y is kind of like negative 1. So basically, I just want to divide negative 1 into everything. So then I get a positive y, a positive 7x, and a positive 2. And there would be our answer. All right, there we go. Okay, let's take a look at 15. Now, let's see, I guess you can try to do this whole side maybe. 15 to 24, I suppose. If you want to do less, you can just pause it after I'm doing the others. I'll assume you're doing this whole page. Okay, now number 23 and number 15 may give you trouble. So if you're not sure how to do those ones, just skip them and we'll go to the other parts, okay? Alright, so pause the video. Now when you've given enough time, you can work on these ones. And, well, I guess you can see how these ones went. Alright, so you should have paused that. So let's take a look. I'm going to skip 15 for now. I'm going to come back to it, okay? There's something special about vertical lines. Okay, so let's just look at number 16 first. So we start off by finding that y-intercept, right? So our y-intercept here is -1. And then I need another point, which looks like I've got one right here. So again, we go left to right. So for my slope, we go up 1, 2, 3, 4 to the right 1. So slope of 4 over 1, which I'm going to reduce to just 4. So my equation is y equals 4x minus 1. Okay, number 17. Looks like we've got a good point here, here, and looks like here. So my y-intercept here is -2. Okay, and my slope is, I'm going to go from the two farthest ones. 1, 2, 3. If you were stopping at -2, that'd be 3, but I'm going to go 4, 5, 6. 1, 2, 3, 4 if you stopped at -2. So it's really going to be 3 over 4, isn't it? 1, 5, 6, 7, well, 4, 5, 6, 7, 8. So I'd either get 3 over 4, 6 over 8, which 6 over 8 reduces to 3 over 4. So a slope of 3 over 4. So I go y equals my slope, 3/4 x, and -2, which is my y-intercept. Okay, number 18, y-intercept of -2 again, right? So you can write it out like this every time if you need to. Then a slope of, looks like this point right here, so I go down 1, so -1, to the right 1, 2, 3, 4, 5. So slope of -1 over 5. So it's y equals -1/5 x minus 2. All right. Okay, 19. And if you need to pause to catch up, just let Mr. Vorwaller know. Okay, y-intercept of -5. Find some good points. Looks like right here. 1, 2, 3, 4, 5, 6, 7. So down 7. 1, 2, 3, 4 to the right 4. So a slope of -7/4. So y equals -7/4 x minus 5. For number 20, this guy's really steep, isn't it? So this point right here, sometimes it's hard to see the points. It looks like this point right here. So a y-intercept of +5, a slope of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1. So 10 over 1, which would just be 10. So an equation of y equals 10x plus 5. A little bit easier one, isn't it? Nah, I don't know. I guess not necessarily. Numbers to write without fractions are easier. Y-intercept here of +2, right? So y-intercept of 2. And my slope, looks like there's another point, so I can go up 1 to the right, 1, 2, 3. So it'd be 1 over 3. So I go y equals 1 over 3x plus 2. Okay, 22. We've got points here, 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 and here. So I could go up 2 to the right 1, or I could go up any number here, but it's always going to reduce to 2 over 1. So slope of 2 over 1. Y-intercept of +3. So I go y equals 2 over 1, which is just 2x plus 3. All right, let's skip 23 as well, and let's just look up 24, and then we'll go back to those other ones. So good point here, here, and here. So I'm going down 3, -3 to the right 1. Y-intercept of -1. So I go y equals -3 over 1, which is just -3x minus 1. Now, for 23 and 15, okay, let's talk about these ones. So they're actually pretty simple. For 23, if it's a horizontal line, it's just going to be y equals whatever basically the y value is, which in this case would be -5. But here's why it works, okay? So that's easy to see, that's my y-intercept, right? Then my slope, notice I have no vertical change, okay? So my vertical change would be 0. Then I'd have any number of horizontal change, however decided to put the points, okay? Say it's 5. Okay, 0 over anything is going to be equal to 0. So my slope is 0. So if I get y equals 0x minus 5, well, 0 times x is 0. 0 minus 5 is just -5. So anytime you have just a horizontal line, it's going to be y equals then whatever number it is. Okay? Now, the vertical one kind of works the same, except not the same. Because you would look at this and say, oh, it's like the other one. It's flat, so it's going to have no slope. So it's going to be y equals -5 again. But that doesn't make sense, does it, to have the same exact equation for a completely different line. So we think of this differently. Our slope is rise over run, isn't it? So vertically here, if I pick 2 points, I'm going to have a number. I went up 2. But I have no run. My run is 0. So I'd have 2 over 0, or any number over 0. Okay, this isn't 0. This is actually undefined. You cannot divide by 0. That makes no sense. You can't have a certain number of 0 parts. Okay, it doesn't work that way. So because of that, we actually don't have a y in here. But we do have an x value because it's never going to cross the y-axis, is it? Because it's a vertical line. So anytime we have a vertical line, it's going to be x equals and then whatever number. So if you see x equals something without the y, it's a vertical line. If you see y equals something without the x, it's going to be a horizontal line. Okay? So, all right, now we got the last batch to do. So if you haven't done these already, make sure the video gets paused. Work on these ones, and that should take you, then you can watch this, and I should finish you up. Okay, so pause it now. All right, so let's dive right into these and finish this out. So now I have a y-intercept of 0, don't I? Okay, that's all right to have. Now I find another good point, which looks like it's either here or here. So I'm going to go up 1, 2, 3. All right, 1, 2, 3, 4, 5. So I have a slope of 3 over 5, which if I wanted to, I could put m equals 3 over 5, because m stands in for slope. And then I could, for my y-intercept of 0, I could just put b equals 0, because it's y equals mx plus b. Okay, so I go y equals my slope 3/5 x plus 0. Now, when we have our y-intercept at the origin, we can just drop that plus 0, and we can just leave it that way. Okay. All right, 26. Y-intercept here at -3. Point right up here, so I'm going to go up 1, 2, 3, 4. All right, 1, 2, 3, 4, 5. So slope of 4/5. Okay. And a y-intercept of -3. I'm going to go y equals 4/5 x minus 3. Again, you could put plus -3, but I would just put -3. 27, we've got our y-intercept of -5. Point right here. So I go down 1, 2, 3, 4, -4, to the right 2. So -4 over 2, which reduces to basically -2, right? So -2 for my slope, -5 for my y-intercept, so I get y equals -2x minus 5. Make sure you're not mixing up the numbers either. The x always goes with the slope. Y-intercept of 0, okay. Slope of 1, 2, 3, 4, 5, down 5 to the right 1, 2, 3. So -5/3 for my slope. Again, because b is just 0, we don't even need to write it, so I get y equals -5/3 x. Could put a plus 0, but I don't have to. Okay. All right, so last 4. Okay, so we've got points here, here, and here, and here. So going down 1, 2, 3, so down -3 to the right 1. Slope of -3 over 1, so my slope is -3. On a y-intercept of -5, so I go y equals -3x minus 5. So hopefully things are making more sense for you on how to do this. So I go down 2 to the right, 1, 2, 3, 4, 5. So a slope of -2/5 with a y-intercept of -3. So y equals -2/5 x minus 3. Okay, 31, y-intercept of 0. Slope of, looks like we go up 4 to the right 5. So a slope of 4/5. So y equals 4/5 x plus 0, or just drop it off. And finally, y-intercept of +1 and a slope of up 2 to the right 1. 2 over 1, which is just 2, so slope of 2, y-intercept of 1, we get y equals 2x plus 1. Now, hopefully you've noticed that anytime as we look left to right, anytime this is going down as we look left to right, my slope's negative, okay? Because it has a negative slope. Anytime we're going up as we look left to right, my slope is positive, okay? Hopefully you've noticed that. So, there's some good practice. You guys should be ready to do well on this when it's time to be quizzed, okay? All right, there we go.